Suppose a suppose omega ft fn n greater or equal to 0 and p be a filtered probability space, and xn be a sequence of integrable random variables adapted to the sigma algebra Fn. Such that for all n greater or equal to 0 we have conditional expectation of xn plus 1 given fn is equal to n times xn plus 1. Now the question is xn a martingale? And find two sequence an and bn such that capital Mn is equal to small an time random variable xn plus bn is a martingale with respect to the above filtration. Now if xn was a martingale, then conditional expectation of xn given the filtration fn is xn. This implies that n time xn plus 1 is equal to xn, which is not possible for x1. Why? Because if n equal to 1, then x1 plus 1 is equal to x1. So this means 1 equal to 0. So that's a contradiction, right? Another way to see this, to observe this, xn is equal to 1 by n minus 1, which is equal to constant, and the property expectation of xn is equal to expectation of xn minus 1 dot 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 expectation of x0 is not true. So for martingale, we know that these expectations are always equal, but for these random variables, the expectation depends on the time n, so it's always changing because of this. Xn is equal to 1 by 1 minus 1 by n minus 1, so this is not a martingale. Now for the question number 2, from the martingale condition, we have conditional expectation of mn plus 1 given fn is equal to mn. This implies an plus 1 xn plus bn plus 1 given fn is equal to an xn plus bn. This implies an plus 1 xn plus 1 given fn plus bn plus 1 is equal to an xn plus bn. This implies an plus 1 xn plus bn plus 1 is equal to an xn plus bn. Since xn is martingale, no, sorry, this line is wrong. So then an plus 1 in into n time xn plus 1 plus bn plus 1 xn plus bn. So this is given expectation, conditional expectation of xn plus 1 given fn is given this expression. I forgot, sorry. So then if you identify the coefficients, then you will get this kind of relation. N plus 1 is equal to an equating coefficient xn from both sides and bn plus 1 plus an plus 1 is equal to bn. So this and this. So from the first equality we get an plus 1 divided by an is 1 by n. So this, if you an will be a1 by n minus 1 factorial by taking a1 is equal to 1, you can get an is equal to 1 by n minus 1 factorial. So from this an by an plus 1 by an is equal to 1 by n, this n equal to, so this there is a step jump here. So how did you get this? If you do not understand, then comment below. So all you do is just like put n equal to 0, n equal to 1, and then do the product, and then terms will get cancelled out and you will get something like that. And then since we do not have to, since we have to get only one sequence, you can put a1 some number 1. And similarly, for the bn, so here you get this relation and it will be a sort of series of product, but for the bn you will be some telescoping sum, and you will, all terms will get cancelled out and you will get like bn is equal to b0 minus j from 1 to n 1 by factorial j minus 1, and you can take b0 is equal to 0. So finally you get an and some bn, so that this is becomes martingale.